FADU OEM SSD offering. In this presentation, we will be talking about some of the industry trends and how they're changing with the OEM server and storage and how FADU serves this market. My name is Anu Murthy and I'm VP of Marketing at FADU. In this slide, we talk about OEM server and storage CPU roadmap. AMD were first to the market with a Gen4 interface in 2018. Intel was a little late to the market with Ice Lake in 2020, but they quickly followed suit with Sapphire Rapids in 2021 with a PCIe Gen5 interface. The server are the first to adopt the new generations of PCIe, followed by storage. What's accelerating the generational shift? HPC, AI, ML style workloads drive compute MIPS and servers and the associated storage performance to the next nodes. Latency-intensive applications and mission-critical workloads will still have a significant on-premise component. Private cloud is trying to pull in mission-critical workloads, and they use primarily OEM boxes, pushing SSD performance to the next node. Starting 2020, there will be an unprecedented fall in NAND flash pricing, which will last right up to 2022. This is in part due to COVID oversupply and soft demand, transition from 96-layer to 128-layer, and the addition of YMTC supply. As you can see from the graph above, QLC is headed from 7.5 cents a gigabyte in 2020 all the way down to approximately 3.5 cents a gigabyte in 2024. It also accounts for 27% of the supply in 2024. This makes the conditions ripe for the adoption of QLC SSDs eating into the HDD space. ZNS, the same streaming interface for HDD and SSD, which sequentializes traffic before it writes to media, will enable the use of QLC NAND in a big way. There are two flavors of ZNS, one that permits fast backup for high-speed random access data, and the other one that just reduces over-provisioning. Both these flavors are seeing rapid adoption in the industry today to enable QLC adoption. What is the effect of all these on flash controllers? As a percentage of the SSD cost, the flash controller cost is increasing. Design efficiency, in this case, is pretty critical. Generational scalability enables a higher total cost of ownership. Broad NAND flash supplier base is essential for hyperscalers, and its compatibility further enables rapid and flexible SSD introductions. Workload customizations become key, and telemetry customizations are required for maintenance and supply chain. At FADU, we introduced our flagship Gen3x4 Bravo SSD. It is a high-performance, low-power SSD. We will follow it up with early 2021 to meet the Ice Lake with a Gen4x4 SSD. This Gen4x4 SSD will support both enterprise as well as hyperscale flavors. It is a dual port with an E1.S and a U.2 form factor. And in 2022, we will follow it up with Delta Plus to meet the QLC SSD, which is able to bear a little more loading, and an Eco Gen5x4 to meet the high performance requirements of Gen5. Now let's talk a little bit about FADU Bravo, our Gen3 storage platform, and its successes. This slide talks about the competition between FADU Bravo SSD and the current leaders in the market on a U.2 node, 2 TB at 7% OP. This is one of the most popular configurations in the server and storage space today. The performance of FADU Bravo on sequential read is 3.3 gigabytes per second as opposed to 3 gigabytes per second. On sequential write, it's 2.6 gigabytes per second as opposed to 1.4 gigabytes per second. On random read, it's almost double the performance of the current leader, and on random write, it's almost double the performance. On KIOPS per watt, it is almost double the performance of the current leader in the market. This slide demonstrates one of the real-life examples of FADU Bravo PCIe Gen3 versus the market leader. Both of them were put on a server and were exercised on a lot of read. As you can see, the market leader throttles under full performance conditions and the QoS varies a fair bit. FADU does not throttle much, and that not only gives it a higher performance but also gives it a much better QoS. FADU Bravo Gen 3 has been qualified with multiple NANDs. We've qualified it with Kioxia, Micron, and SK Hynix NAND. We've passed multiple qualifications with hyperscale vendors, T2 Cloud, OEMs, and SSD suppliers. FADU Bravo Gen 3 supports hyperscale cloud storage and OEMs. In this section, we will talk about FADU DELTA Gen4 storage platform. In this slide, we'll be talking about our DELTA Gen4 SSDs. They support PCIe Gen4x4 in dual-ported or single-ported mode and are backwards compatible with PCIe Gen3 in dual-port and single-port mode. We support the NVMe 1.4a and OCP 1.0 specifications. We support eTLC, cTLC, QLC NAND, and XL Flash, which is the low-latency NAND from Kioxia. We support capacities up to 16 terabytes. We support a sequential read of 7 gigabytes per second, a sequential write of 5 gigabytes per second, a random read of 1.6 million IOPS, and a random write of 450K IOPS. It is available in the U.2 and in future in the E3 form factor for OEM server and storage, and in the E1.S and M.2 form factor for hyperscale cloud. The DELTA U.2 Gen4 SSDs are dual-ported, and they support enterprise features such as SRIOV, end-to-end protection, high reliability, security, ZNS, and a path to transition from E1.S to E3. With Bravo SSD, we established ourselves as the leaders of this class in the low-power, high-performance SSD. We beat competition in almost all of these categories. With DELTA Gen4 SSD, we consolidate this lead by doubling in every performance parameter. We double our capacity, our sequential read, sequential write, random read, random write. But in power, we consolidate our leadership by only consuming 1.5 times the power of the previous generation. The leading vendors in the industry have announced their Gen 4 drives. Their performance is in the table on the left side and the FADU Delta's performance on the right-hand side. As you can see, in every category, we beat the performance of the competition. On sequential read, at FADU Delta, we're about 8% faster than the competition. On random read, we're up to 197% faster with FADU Delta. Our KIOPS per read far exceeds everybody else in the industry. On sequential write, we're up approximately 209% faster. On random write, we're approximately 500% faster. Our KIOPS per write is much better than anyone in the industry. Our power remains much lower than the rest of the industry. This slide shows our schedule for the DELTA SSD release. In Q1 2021, we're able to distribute engineering samples of our DELTA SSDs. In Q2 2021, we will have customer samples. The first samples to come out will be in the E1.S, the U.2 form factors, and they will support eTLC, followed by possibly E3 form factor and CTLC, QLC, and XL flash as required. We will describe the business models for working with FADU. We established ourselves with our Gen3 FADU FC3081 controller. We've provided a stable, customizable code base which has worked seamlessly in a variety of environments. We've ported our code base to SK Hynix NAND and Kioxia NAND flash from the ChargeStrap variety, as well as Micron B27A from the floating gate variety. Our Gen3 controller has been qualified by 4 major vertically integrated NAND flash suppliers, 2 other flash SSD vendors, and 2 white box vendors. Our Gen4 controller is ready for qualification in 2021. We have 3 flash supplier choices: SK Hynix, Kioxia, and Micron. At FADU, we have flexible business engagement models. First, we have a turnkey design model where FADU supplies the SSD design, controller, and firmware, and the OEM builds their own SSDs and may customize the firmware. We also supply a consignment model where FADU supplies the SSD controller, design, and builds private labeled SSDs. The OEM consigns their NAND flash to us. And the third is a channel to distribute FADU SSDs. Thank you.